In this session, we're going to see what arithmetic sequences and series are. Yeah, it looks like arithmetic, but it's being used as an adjective, and when it is so used, it is pronounced arithmetic. Sequences have terms that are separated by commas. Series happen when you add things together. Keep that in mind. The distinction will become a little bit clearer later. An example of an arithmetic sequence is 1, 4, 7, 10. I bet you can tell what's coming next. As soon as you can tell what's coming next, mathematically speaking, we can put ... How would you figure out what's coming next? Well, you look at a pattern, right? You say, well, look, 4 and 1 have a difference of 3. 7 and 4 have a difference of 3. 10 and 7 have a difference of 3. My money's on the next term also having a difference of 3. So I'd say the next term is probably going to be 13. If you can add the same thing to a term each time to get the next term, it's an arithmetic sequence. Another example of an arithmetic sequence would be 8, 3, -2, -7, -12. And I'm going to put a comma and a ... indicating it keeps going as you would expect. And we're going to find out the difference between terms in the same way. If we take 3 minus 8, we get -5. The difference between -2 and 3 is also -5. Between -7 and -2 is also -5. So I'm adding the same thing each time to get the next term, and that makes it an arithmetic sequence. In this case, it's a decreasing arithmetic sequence, but it's an arithmetic sequence nonetheless. Since these are sequences, it would be appropriate to assign sequence notation to them, and in that case, for 1, 4, 7, 10, the first term would be a sub 1, the second a sub 2, a sub 3, and a sub 4. If we did a quick plot with, instead of the x-axis, an n-axis, indicating the subscripts of the terms, 1, 2, 3, 4, and we plotted the values, 1, 4, 7, and 10, what would happen is we would end up with something that lines up really well. Now, it's not actually a line, so let me get rid of that. They're dots, because they're just term by term, but the dots line up in a straight line. That's characteristic of an arithmetic sequence. If we looked at the other one, then the first term is 8, the second term is 3, I'm just doing a quick and dirty thing here, third term, -2, fourth term, -7, and we can see that these also line up in a straight line. If I had done it perfectly, it'd be a great straight line. It's not that it's a solid line, but it's that they have roughly the shape of a line. We talked about sequences before, and we looked at an nth term. And it's not going to be any different here. We're looking at a sub n, and in each case we're adding the same number to get subsequent terms. And so if I scroll up here, this number that we're adding, in the first case it was 3 each time, right? 1 to 4 to 7 to 10, each time we were adding 3. That number is denoted by a D, and it's called the common difference, because every time we subtract one term from the next term, we get the same common difference. In the case of the second sequence, where we have 8, 3, -2, the common difference turns out to be -5. That it's negative just means it's decreasing, but in this case, -5 is what I would add to each term to get the next term. The nth term of an arithmetic sequence depends on the first term, a sub 1, and adding the common difference. So I'll throw in the common difference here, and it's going to be added every time, but look, for the first term itself, there's nothing that you added. It's just there. For the second term, you added the common difference once. For the third term, you had to add the common difference twice. This pattern emerges that says, the common difference got added one fewer time than the term you're looking at. Look, for the first term, you'd have a sub 1. The second term, a sub 2, would be the first term plus the common difference. The third term, a sub 3, would be the second term, a sub 2, plus the common difference. It's always the common difference. That's why they call it a common difference. Note that a sub 2 is a sub 1 plus d already, right? So a sub 3 would be a sub 1 plus d, right? That's our a sub 2, plus d, the common difference. That is 2 d's. Bringing this together gives us a sub 3 is equal to the first term and 2 d's. We're just going to keep adding that same d over and over and over, right? So the multiplier in front of d, that factor, in this case 2, is 1 less than the subscript that we're talking about. So the nth term has the form a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Let's see if we can use this information in our first example. Find the nth term of the arithmetic sequence 1, 4, 7, 10, etc. Well, I see that the first term is 1, and as we already noticed, the common difference is equal to 3. Again, I can get that by doing 10 minus 7. I can verify it by subtracting 4 from 7. 4 minus 1 is also 3, and so there's that common difference. That's how you'd find it if you didn't already know it. Notice that the second term is what happens when we take the first term and add the common difference. The third term is what happens when we take the first term and add the common difference twice, just as we said before. So, keeping in mind that the nth term of an arithmetic sequence looks like a sub n is equal to a sub 1 plus n minus 1 times d, our nth term for this sequence, 1, 4, 7, 10, is going to be a sub n is equal to, a sub 1 is the first number, the first term, plus n minus 1. This is where we go generic, because it's just a sub n, right? That n minus 1 is going to be times d, but d in this case is 3. We can simplify this here. So a sub n is equal to 1 plus 3n minus 3, or 3n minus 2. That's it for this one. On to the next. Find the nth term of the arithmetic sequence 8, 3, negative 2, negative 7, negative 12. Negative 12 minus negative 7 is going to turn out to be negative 5. Negative 7 minus negative 2 is going to turn out to be negative 5. And we can quickly mentally verify that it's going to be negative 5 every time, indicating that the common difference is negative 5. The nth term is the first term, a sub 1, plus n minus 1 times d, the common difference. So in this case, the nth term, a sub n, is equal to the first term, 8, plus n minus 1 in parentheses, times the common difference, negative 5. Again, we can simplify this and end up with a sub n is equal to 8 minus 5n plus 5. And so a sub n is equal to negative 5n plus 13. Looks right to me. And there it is, the nth term. If we wanted to verify that this was correct, we could put various numbers in place of n and make sure that it coincides with the terms that we have, and I leave that to you. You are highly encouraged to perform that verification. I am going to move on to the next example, which is to find the 12th term of the arithmetic sequence whose 4th term is 6 and whose 8th term is 22. Holy cow, that's a lot of numbers. Let's break this down a little bit. Find the 12th term. Pause. We need to find a sub 12. Keep going. Of the arithmetic sequence, it's going to have a common difference. In fact, I'm going to write down what I know right now about arithmetic sequences, and that is the nth term, a sub n, is equal to a sub 1 plus the quantity of n minus 1 times d. Back to the reading. Of the arithmetic sequence whose 4th term is 6, pause, a sub 4 is equal to 6. That's the 4th term. And whose 8th term is 22. So a sub 8 is equal to 22. Using the formula for the nth term, we can write down something about a sub 4 and a sub 8. A sub 4 is 6, which means that 6 is equal to a sub 1 plus 3 times d. Remember, we're looking at 1 less than the subscript for the factor on d, right? And a sub 8 is equal to, what do you think? A sub 1 plus 1 less than 8, 7 times d. If I rearrange these just a hair, I have 22 is equal to a sub 1 plus 7d, and 6 is equal to a sub 1 plus 3d, and oh my gosh, we have a real live system of equations. The unknowns are a sub 1 and d, and if I subtract the second equation from the first equation, I'm going to eliminate the a sub 1's. The result of this subtraction would be 22 minus 6 is 16. That's equal to, a sub 1's are gone, 7d minus 3d, don't forget we're distributing that negative, is 4d. This tells me that the common difference is equal to 4. That's a lot to know. But let's look at what we need to find out. We need to find a sub 12, right? And a sub 12, according to the equation that we have for the nth term, is going to be a sub 1 plus 11 times d, right? What I do know is d. What I don't know is a sub 1. In other words, we need to finish solving this system. So, as you may recall, you better recall, to solve a system, once I have one variable, I can just plug that into either of the original equations. So I'm going to use 6 is equal to a sub 1 plus 3d. d, though, we just found to be 4. So 6 is equal to a sub 1 plus 12, which means that a sub 1 is equal to negative 6. Hey, I don't like that it's negative either, but I do what the numbers tell me. And putting together that d is 4 and a is negative 6 into our formula for the nth term, we can say that a sub 12 is equal to negative 6 plus 11 times 4, negative 6 plus 44, and negative 6 plus 44 is equal to 38. We were asked to find the 12th term. We found it, it's 38. The sum of an arithmetic series is denoted S sub n, and what it refers to is adding up n terms, like a sub 1 plus a sub 2 plus a sub 3, and then I don't want to be specific the way we be generic with this. B, the way we can write this in a generic way is plus dot 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 plus a sub n. And I don't often do this, but I'll just give you the formula. The sum is n divided by 2, n being the number of terms, times a sub 1 plus a sub n. In other words, it's the first term and the last term added together, multiplied by a number that's n divided by 2. recalling that a sub n is equal to a sub 1 plus n minus 1 times d, this formula can be rewritten. I'm going to replace a sub n with what it is, a sub 1 plus n minus 1 times d, and s sub n could be rewritten as n over 2 times a sub 1 plus a sub 1 plus the quantity of n minus 1 times d. I guess I should have brackets there instead of parentheses, which would become s sub n is equal to n over 2 times, no, brackets, times 2 times the first term plus n minus 1 times the common difference. So I'm going to circle the two formulas, and really you just use whichever one seems prudent to you at the time, right? If I am given a first term and a last term and I know the number of terms, I might use the first formula. If I don't know what the last term is, but they tell me, hey, find the sum of the first 12 terms or something like that, then it might be easier to use the second formula, but really they're the same formula. Let's see how we might use these. Find the sum of the first 11 terms of the arithmetic sequence with first term 4.5 and common difference 0.5. So we need to find the sum of the first 11 terms, s sub 11. And the first term, a sub 1, is 4.5, and the common difference, d, is 0.5. So do I have enough information to use the first formula we had? S sub n is equal to n over 2 times the quantity of a1 plus a sub n. You know, I don't know the nth term, and I don't really want to figure it out just to do this sum. So maybe it would be better for me to use s sub n is equal to n over 2 times the quantity of, oh wait, that was brackets, 2 times the first term, 2 times a sub 1, plus n minus 1 times d. Do I have all the information to use this formula? Let's check. I want the first 11 terms. That's n is equal to 11. So I have n. Check that. The first term is 4.5. We already wrote that. So I have the a sub 1. Check that. Common difference is 0.5. So I have the common difference. I am going to use that version of the formula. So s sub 11 is equal to 11 over 2 times 2 times the first term, 4.5, plus n minus 1, since it's the first 11 terms, n is 11, and so n minus 1 is 10, times the common difference, which in this case was given to be 0.5. So s sub 11 is equal to 11 over 2 times 9 plus 5. That seems to me to be 11 over 2 times 14. And since 2 divides into 14 7 times, the sum of the first 11 terms is equal to 77. So this is a rare occasion. I give you a formula, show you how to use it, move on. Let's move on. Find the sum of the arithmetic series. You see I'm using the word series here because we have a bunch of plus signs. Find the sum of the arithmetic series -6 plus 1 plus 8 plus 15 plus missing terms, ... plus 50. -6 is the first term. That's obvious. 50 is the nth term, but I don't know what n is. What I do know is that a sub n is equal to a sub 1 plus n minus 1 times d. I know a sub 1 is -6. I can pretty well figure out d, I think, Remember, d is what happens when I subtract a term from the next term. So, and it's got to be backwards. Okay, that's how you get the common difference. So 15 minus 8 is equal to 7. That's the common difference, and I would say maybe 8 minus 1 is 7 to verify that it's arithmetic, but I was told it's arithmetic, so we're good there. Hey, what I just found out is that d is equal to 7. What I don't know is n. So I'm going to have to flesh out the nth term formula using the nth term, a sub 1 and d. So a sub n, which is 50, is equal to the first term, negative 6, plus whatever n is, minus 1, times the common difference of 7. Now, look, you can distribute if you want. That's fine. I'm not going to bother in this particular case. What I'm going to do is I'm going to add 6 to both sides of the equation with the numbers. And so I have 56 is equal to n minus 1 times 7. Since I'm after n, I want to kind of leave that alone. I'm going to divide both sides by 7. Those divide out. I have 8 is equal to n minus 1. That tells me that n is equal to 9. Now I know n is 9. If we scroll up a little bit, the first term is 6, the last term is 50, and we had this formula. It was really cool. It was s sub n is equal to n over 2 times a sub 1 plus a sub n. Which means in this case, we have s sub 9, the sum of the first 9 terms, which we found out, is equal to 9 over 2 times a sub 1, which is negative 6, plus a sub n, which was 50. So s sub 9 is equal to 9 halves, don't go decimal or anything until you know you have to, times 44. Since 2 divides into 44 22 times, the sum of the first 9 terms is 198. Why aren't I done yet? Wrapping up. Okay, the nth term of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. You should probably have that memorized by now. The sum of an arithmetic series has two formulas. S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. That's if you happen to know the last term. Or S sub n is equal to n over 2 times 2 times a sub 1 plus n minus 1 times d. That's the one you might use if you don't know explicitly what the last term is. And this wraps up arithmetic sequences and series.